Hey guys, welcome back. The last 3 months I didn't do a mailbag video, but today it's again time to show a few interesting pieces that I bought. For example, I bought for the first time 100 meter of cable. This is 100 meter of 0.14 square millimeter cable. That's not really interesting, but I think it's something cool because for me it's the first time buying 100 meter of cable. But here are many other things that I was showing, and we will go into detail on a few pieces, but not all of them. Okay, let's start with the least important items. For one, I bought again a whole bunch of these 2-pin connectors. This is the style that I really like using in my projects, and I ran out of them, and I bought 20 pairs. I think it's 20 pairs, male and female, 20 pairs of 2-pin connectors. I really like them because I don't have to terminate the cables myself. I can just solder them to longer cables or into my projects. Well, this is one thing. So the next thing I bought is a bunch of these switches over here. You have a center connection. You can decide to either switch the bottom part if the lever is on top, or the top part, the top pin, if the lever is on the bottom. I like these kind of switches because if you install them like this, so this is in a project, let's say this is a project, they are installed and it points up, this is the on position, and you can just push it down to the off position, or in the middle, which is also off. It's not really necessary. I just like these switches because having a bunch of them just looks cool. And the last thing are these over here. Now these are male and female DC jacks. I really like these female connectors. I even use them just on cables. You can bend the pins in whatever position. You can remove the outer pin over here and just use them as a cable or install them in projects. And I have the male counterpart, and this one you can remove the black plastic housing and then wire up accordingly. You can either use the middle pin as your positive or the outer metal as positive, but typically the middle pin is positive and the outer metal is your ground or negative. If you wired differently, you have to keep in mind that you can't use these for off-the-shelf products. However, I always wired according to standard, so middle pin positive, outer housing negative. It's really useful, and I need a whole lot of them. And now onto something that is a bit more interesting. I bought a whole bunch of these hooks over here. You can hook onto cable and probe something. I made my own custom cable for my multimeter, but with a different style. So the ones I bought the first time are these ones. Now I bought the smaller version. They have a different hook size, which is not a big deal. They are obviously shorter and a slightly different style, but the internal connection is just the same. You remove the top part of the metal inside, you can solder onto. And if I remove the top part over here, okay, that's not what I wanted to do. Oh, I see, I can't remove the top part anymore. Essentially, they look the same inside. I have to repair that later on. Well, that's unfortunate. However, they're essentially the same. You have a metal part inside made from brass, I think. A spring, as you can see, a spring inside. This makes sure that the hook always stays in here. If you press it down, the spring gets compressed, and the counterforce then lifts the hook back up. And you have to feed in the cable through this hole, so you can close up the hook. And there's also a way it has to go on. I think it's this way. I'm going to do that off camera. So these are very interesting. Always nice to have such hooks, not only for multimeter probing, but also the project that I have to start is this over here. This is maybe you guys are already familiar. This is a component tester. And these are nice devices. You can test all kind of components and you can see if they still work or get some variables. They work really well, but one problem is this connector over here. I don't know how this is called, but the problem is with bigger transistors. They don't fit inside because you can see here it's marked pin number 1, 2, 3, and all of these are pin number 1. So if they don't fit in here, you can't probe. But what you can do, however, is connect on the back side to these pins, pin number 1, 2, 3, and then use these hooks. These hooks can hook onto a transistor or any component that's too big. So you can probe it. Now, let me show you. Okay, I just grabbed a few MOSFETs. So the size that fits in is like this size. So you can get the legs inside, hook or push the lever and have a connection. This works. But if you have bigger components like these IGBTs, well, that's not going to work because we have pin number 1 on the left leg and pin number 1 on the right leg. Yeah, so instead I'm going to use some of these. You can see I can just hook onto and then probe. But that's a thing for another video. These hooks are really a nice thing to have, not only for component testers, not only for multimeters, but also oscilloscopes. If you want to make your own probes, you can make an adapter from you can get one of these cheap cables over here, cut off the end, or rather here, cut off these crocodile clips and install these hooks instead. Next up is this heating element over here. Now this is the heating element from a heat gun. It's a, I think, 1000 watt heating element. It has a temperature protection thingy, also called a thermostat, installed for overheating protection. It's directly powered from mains voltage, 240 volt, 230 volt, and we do have these connections over here. They go on the top to this thermal element, this small piece over here, and that is how we can measure the temperature. So you have to have some airflow from the bottom going through these metal thingies. They are oriented like a star pattern around the core. What is this material? Yeah, that's a ceramic material. So it goes around, air comes through. This small piece over here measures the temperature. This is just the contact for the heating element. That's the lower contact, that's the upper contact. We feed in 230 volt AC. It heats up, but it needs air movement. I actually bought this before Christmas, before I knew I was going to get a hot air rework station. What I wanted to do is make my own with one of these heating elements. But now that I have a hot air rework station, I don't really have to do that. So this project, I will still do it, but this project just will be somewhere in the future. Alright, and next up we have some GD900. This is thermal paste, and several months ago I heard that the GD900 is very, very similar to Arctic MX4. I can't pronounce that. And if this is true, if this actually performs just as well as Arctic MX4, I'm definitely going to buy more of this, because this is really cheap. This is, I think, 30 grams, and only cost, 30 grams, and only cost $5. Whereas the MX4, if I remember correctly, you get 4 grams within Germany, 4 grams for 6 euros. So if this performs similar, I'm definitely going to buy more of this. Okay, and here we have a special holder for 18650 cells. Now this type of holder is very good if you want to make something where you have to insert and extract 18650 cells multiple times. And here you can see if I install an 18650 cell, it sits inside, and it's easy to remove. Easier than with the other types that do always have this curve that holds the cells in place. It's still rather difficult to get them out. There's a lot of force through these springs, but it's a much better design if you want, for example, to build a charger, which I'm going to do with this. And I can fit in 4 of these cells. I just only have 3. And I will then use the BMS charger circuit that I showed in previous projects to individually charge the cells. That's a really great thing to do, because you don't then have to have 4 cells installed to charge it. Next up is this thing over here. Now these are some multimeter probes, and several years ago I bought this pair, but the original product page is no longer available. And I hope that these are the same as the ones I already bought, because the ones I already bought, they were advertised as gold-plated probes. And because of their performance, I strongly believe that they are gold-plated. Okay, so let's use the multimeter and see how they perform. I hope they perform the same. Okay. They are worse. What? Okay, let's do a side-by-side comparison. My old probes and the new ones. It sometimes lacks connection, so the probes are not as good as the old ones. And here we got 2 blower style fans. And the reason I bought these ones were because of my heat gun project. I wanted to use 2 of them to have enough power to get air moved through the heating element, although I plan on using one first and then trying if this wasn't enough air movement to have the other one. But now I don't need them right now, and because I have my heat gun, the new version, what am I talking about? The one I got for Christmas, and I saw there's only a single blower style fan installed and a similar heating element, so one will be enough. So I have one extra, which is cool. And I think what I'm interested in is to see how much noise they produce. They are 12-volt fans. Let's go for 9-volt first. Oh, that's not a whole lot of noise. I was expecting more. Let's go for 10-volt. And 12. Yeah, that's definitely audible. So, and the reason I show you this, by the way, and also the heating element. So the heating element is just interesting. But these, when I bought these ones and I got my new hot air rework station over Christmas, I had to think about something else that I could use them for. And I think if you do projects similar to mine, it's a good thing to have different kinds of fans, different kinds of heat sinks. I do have a collection of different fans and heat sinks, but I don't have blower style fans. So these are the first ones. And they're really interesting because of the way they are designed. They get air from one side, from the big side, and they funnel the air into this smaller space over here and get them to the side. So I think it's definitely worth having a few of them laying around. And now to the LEDs. I do have a whole bunch of different LEDs. I've got 50, I think it's 50 of these LEDs over here. Now they are all white and more in the neutral spectrum. They have a really small dome, not really big, and I've bought other ones that have a bigger dome, and I only got 20 of them. Funny thing is, I've got 50 of these for the same price as 20 of these. The difference is the brightness of these, I can't remember, but they were essentially, I think, two times or 2.2 times brighter than these ones. At least they were advertised to be much brighter. Well, 2 times or even more. So I'm really interested to see if this is actually true. Let's take a look at the brightness. And let's start with the small ones. Now, the only light within my room is coming through a window. And this LED is now producing all the light. The single LED, and look at that, that's really bright, and it's only one. Now, it's obviously not as bright as the combined power of all my lamps, because if I remember correctly, the overhead LED panel is like 20 watt and each of the lamps is 10 watts, so 40 watts of lighting power, LED lighting power, is not going to happen with this 0.02 watt of lighting power that this LED has. Yeah, but it's really bright. Now let's see how it compares to the other LED, the one that should be 2 times as bright. Yeah, it's definitely brighter, but that's interesting. So this is more like focused, but it's not really much brighter. Yeah, I think they are actually, this is true, I think they are 2 times as bright, but because this one has more light dispersion all around and this is more focused, it looks a bit different. The last LED, or LEDs, are these SMD LEDs. I think they are 1206, and we will take a look at the brightness. Okay, so this is the SMD LED, and wow, that's really bright. That's 0.14 watt of power. Nice. And doesn't get hot. Oh, that's interesting. Now on to the last two interesting pieces. First we have this over here. Now this is a 5-volt fan connected to this weird looking PCB, and let me tell you, this is really awesome. Now this PCB over here is a buck converter, but it's not any kind of buck converter. This is a high voltage buck converter. And high voltage is a bit misleading because typically you get buck converters up to like 40 volt DC. But this thing over here can handle up to 60 volt. And the nice thing is, and also the reason I bought this, if you build a bench power supply with one of the really famous DPS modules. The DPS modules can handle up to, I think, 55 volt. And I, for example, have my DPS module hooked up to a 48 volt DC power supply. But 48 volt is above 40 volt of typical buck converter rating, and I'm not able to drive a fan directly off of the power supply. So I always have to use some resistor to drop it, or an extra power supply to run a fan. But now with these modules I can hook them up directly to the 48 volt supply. It regulates it down to 5 volt and this fan spins. Now the only thing is, I recently upgraded from the DPS 5005 to the DPS 5020. And this one has already a 5 volt fan installed, which I'm using to cool the complete thing. And the power supply itself has its own fan controllers, so I don't really need them anymore. However, if you're using one of the 5005 modules or anything of the DPS modules, and you want to use a 48 volt supply voltage and still be able to cool your components, this is what you have to buy. And I bought 3 of them because, for one, the controller I see is not available in Germany, and this can be used for bigger converters, which is one interesting thing. And 2, they were on sale from, I think, $5 down to $2. Yeah, it's a long time ago. And they're really awesome, so I can supply a higher voltage and still run a low voltage fan. Now let's take a look at one of these. If I now select a very high voltage, 26, 36, let's go to 40 volt. So I'll supply 40 volt to it. Maybe turn off the output first, connect it, and then the fan should just run. Let's see. There we go. There we go. It consumes 1.2 watt of power, so the fan has no current rating, but I think it's a bit inefficient. This is a really interesting product and really helpful for any project where you have a voltage higher than your buck converter rated voltage and you can drive a fan. And the nice thing is, this thing, you can see here are 2 additional pads and they are marked maximum 200 milliamps. So what you can do potentially is maybe look up the controller, change one of the SMD components over here and have a higher voltage to, for example, drive a 12 volt fan, and then use these pads. And as you see, it's rated for 200 milliamps, and that's exactly what a 12 volt fan typically pulls. It's 200 milliamps. Yeah, nice product. Definitely really helpful in some projects. And the last thing for today is this over here. Now this is a buck converter with integrated current and voltage adjustment, hence the 2 potentiometers over here. And this is really helpful if you, for example, want to build a Labbench power supply, like the one I already built in a previous video, which, by the way, I'm currently working on. So let me show you. This thing looks a mess, and it is. So let's get this out. I'm currently working on this. There will be another project, so ignore these parts over here and this. So this is the first power supply. It has changed from the last time, and here you can see this is the exact same buck converter I'm using. Just removed the potentiometers and used other ones, and have a heatsink installed and a bit of silicone to hold the coil in place, because if this is flipped, all the weight of the core is on the 2 coil legs. However, this type of buck converter is really useful. It's only rated for 5 amps, but that's plenty of power, and I think the overall maximum power dissipation or power throughput is 75 watt. Definitely a good thing, and definitely something really useful for power supply projects such as this one, or if you want to make a charger, because you can have any input voltage, get a stable output voltage, obviously lower, hence the buck converter, and current limit everything. Or for LED projects. Just remember, this was actually advertised as an LED driver, because you can limit the current. Yeah. So many applications, definitely something you should keep in stock. Yeah, I hope you liked this video, and if you are interested in projects just like this power supply project over here, I will put a link into the video description. Although I have to warn you, the video is not showing this exact type. I installed the buck converter over here, and it has now a temperature controlled fan. I will put a link also in the video description about a temperature dependent fan controller, which is based on the LM317, which is rather interesting, an interesting circuit. And if you are interested in such videos about power supplies, about electronics, mailbags. Sometimes I do these videos. This is the channel to go to. So I hope you liked this video, and if you did, please leave a like, comment down below, and other than that, thanks for watching and see you next time. Bye!